Now we'll do more examples soon, but why are we doing this? We see that it's not too difficult if the function is one that we can multiply by an exponential function and integrate. It's not difficult to come up with the Laplace transform pair. And that's going to be the case for sine functions, cosine functions, power functions, and other classes of functions. And those classes are the functions that are usually important in solving differential equations. Well, before I talk about why we're doing this, let me introduce just a little notation. I've used f of s for the Laplace transform of a function, big F of s, for Laplace transform of a function, little f of x. Excuse my diction, for Laplace transform of a function, little s. I also use this notation. Script L of e to the alpha t, for example, is 1 over s minus alpha, where this is your little f of t function, this is your big F of s function. I'm saying that the Laplace transform of e to the alpha t is 1 over s minus alpha. Saying, again, under the condition that s has to be bigger than alpha for reasons we've seen. So we have, this is another way of expressing the fact that this function and this function of t and this function of s are a Laplace transform pair. Now, again, why are we doing this? And what good is it to do this Laplace transform? And we can phrase the latter question, which is probably the more relevant. What good does this do us? What good does it do us to have Laplace transforms of some of these common functions? What does any of this have to do with differential equations?